Imagine a world where the demand for electricity is constantly increasing. Cities are expanding, industries are growing, and every day, millions of homes and businesses require a steady supply of power. In this world, nuclear power plants stand as one of the most powerful and efficient sources of electricity, capable of lighting up entire cities with just a small amount of fuel. But how exactly do these towering structures, with their complex machinery and intricate systems, generate the electricity that we rely on every day? Let's take a journey inside a nuclear power plant, where the story of electricity generation unfolds. Chapter 1. The reactor core. At the center of every nuclear power plant lies the reactor core, often referred to as the heart of the plant. This is where the magic begins. The core contains fuel rods, which are long tubes filled with uranium pellets. Uranium is a heavy metal, and its atoms are large and unstable, making it the perfect candidate for nuclear fission, a process that releases a tremendous amount of energy. Nuclear fission is like a chain reaction. When a uranium atom in the fuel rod absorbs a neutron, it becomes so unstable that it splits into two smaller atoms, releasing a burst of energy in the form of heat and more neutrons. These newly released neutrons then go on to strike other uranium atoms, causing them to split and release even more energy. This chain reaction is carefully controlled within the reactor core to ensure a steady and safe release of energy. Chapter 2. The heat exchanger. Now that the reactor core is generating immense heat, the next step is to harness this energy and convert it into something useful. This is where the heat exchanger comes into play. Surrounding the reactor core is a system of pipes filled with water. As the core heats up, this water absorbs the heat and turns into steam. But why steam? The answer lies in the basic principles of physics. Steam has a lot of kinetic energy because its molecules are moving very quickly. This energy can be harnessed to do work, which is exactly what happens next in our story. Chapter 3. The powerhouse of the plant. As the steam leaves the heat exchanger, it is directed towards a large turbine. Imagine a turbine as a massive fan with blades that spin when hit by fast-moving steam. The high-pressure steam strikes the blades, causing them to spin rapidly. This spinning motion is crucial because it is directly connected to a generator, the true powerhouse of the plant. Inside the generator, the spinning turbine rotates a coil of wire within a magnetic field. This movement generates an electric current through the process of electromagnetic induction, a principle discovered by the famed scientist Michael Faraday. The electric current produced in the generator is then sent out through power lines to homes, businesses, and industries, providing the electricity that powers our modern world. Chapter 4. The condenser and cooling towers. After the steam has done its job of spinning the turbine, it needs to be cooled down and converted back into water so it can be reused. This is where the condenser comes into play. The condenser is another system of pipes that allows the steam to release its remaining heat and condense back into water. This water is then pumped back into the heat exchanger to be heated by the reactor core once again, completing the cycle. But what happens to the excess heat that is released during this process? That's where the iconic cooling towers come in. These massive structures are designed to release the excess heat into the atmosphere, usually in the form of water vapor. The sight of steam rising from these towers is a common image associated with nuclear power plants, symbolizing the plant's role in converting heat into electricity. Chapter 5. Controlling the reaction. Throughout this entire process, safety is the top priority. The chain reaction within the reactor core must be carefully controlled to prevent overheating and potential accidents. This is achieved through the use of control rods, which are inserted into the reactor core to absorb excess neutrons and slow down the reaction if necessary. In addition, the entire reactor is encased in a thick concrete and steel structure known as the containment building. This structure is designed to prevent the release of radioactive materials in the event of an emergency, ensuring that the surrounding environment and population remain safe. Chapter 6. From plant to home. As the generator produces electricity, It is sent through transformers that increase the voltage, allowing it to travel long distances through power lines. This high-voltage electricity travels across the country, passing through substations where the voltage is reduced to a safe level before reaching homes and businesses. And so, the journey of electricity from a nuclear power plant comes to an end as it powers our lights, appliances, and devices. What began as a tiny uranium atom splitting inside a reactor core has been transformed into the energy that drives our world.